Hello, investors. Welcome to my company, FertiPlastic. I'm Kevin Lee, the Director of Operations for this company. First of all, as we all know, there are many problems with the status quo because of the plastic pollution and paper pollution problems in our world. Humans have produced roughly 8,300 million metric tons of plastic since the 1950s, which the vast majority of which has been thrown out as waste. Only about 9% of that plastic waste has been recycled, and 12% of it has been incinerated, leaving 79% of it to accumulate on our lands and oceans, harming the environment, the food chain, and ultimately ourselves. These plastics are not biodegradable and cost a lot to make and cost a lot to clean up. They also release microplastics when they are attempted to be cleaned up, which have not yet been studied enough and long enough to see what the harms are with the small microplastics in the air. And also another thing is it harms the plants and animals living under the water, where many of the plastics will be ending up in. Our solution to this problem is something called the stroke. As you can see in the picture, it looks like a very flimsy plastic. However, it's not really plastic, as stroke is a fully degradable bioplastic made using a material called chitosan, which is found in shrimp shells, and a protein from silk called fibrin that mimics the microarchitecture of the insect's exoskeletons, which is why it's called shrimp and silk. Stroke can be used to manufacture objects without the environmental damage caused by conventional synthetic plastics, and rapidly biodegrades when placed in compost, releasing nitrogen-rich nutrient fertilizer. And because chitosan and fibrin are both used in FDA-approved devices already, stroke also may be useful for creating implantable foams, films, and scaffolds for surgical closures, wound healing, tissue engineering, and other medical devices. So let me tell you a bit more about the market and this blue ocean strategy. So the higher the number, the better it is. So as you can see here, there's three things. The blue would be our company, FertiPlastic. The more darker, maybe like maroon brown, would be the new up and coming paper products, paper bottles, paper, just like paper replacing plastic. That's the new companies. Even Coca-Cola is on the trend these days. And the red will be the plastic that everyone knows and everyone uses. I have our company, FertiPlastic, very, very high, because at FertiPlastics we actually use gases with the shrimp shells to produce the stroke, which is obviously a lot cheaper than using pulp for paper, and using oil, and many liters of oil actually, and many more liters of water to actually create the main thing, the plastic bottles that are polluting our world. Another thing is consumer cost. Of course, the cost will be around the same. It won't change much, as we need to compete with the other companies. But our environmental impact is so huge because we are actually biodegradable. While paper is also biodegradable, ours only degrades in two weeks compared to other paper companies, which may take months to degrade, but it's still better than plastic, which will be taking thousands of years to degrade. And ours is a lot more sustainable because we use shrimp shells and as we all know, shrimp will always be reproducing more and more, and as our company picks up, we will be producing more and more shrimp, which is much easier to produce than trees, which is needed for paper, and oil and petroleum, which is used for plastic. Social image is something that's not too important here, but must also be talked about. Of course, paper products, and our products at FertiPlastic will have much better social image than plastic bottles, which is the traditional thing, as we will be saving the environment. However, as I said, this isn't very important. But the last thing is actually very important: quality of life. Plastics, although they give many jobs to the people around the world, it actually also hurts many people around the world. It hurts fishers, it hurts hunters, it hurts like anyone involved with the food chain and hunting to kill and hunting so that our animals can become food. Oh, but we solve this problem because, like I said, plants can actually live on our technology on this stroke. In only 2 weeks, plants can be grown on our things compared to thousands of years in the plastic things, which makes quality of life much easier for many jobs, but although it might make it a bit harder for the plastic companies to survive. And here next we have competition here. The major competition is SABIC or any of these other huge plastic companies. At FertiPlastic, like I said already, it's biodegradable compared to SABIC, which is not biodegradable, takes thousands of years to degrade. Ours actually fertilizes the environment as we're made using animal scraps. Ours is low maintenance. You don't need these huge factories to grow these shrimps, grow the protein for silk. All you need is gases created by this procedure is actually created by the Harvard Weiss Institution, who first coined this idea, but we're improving on it by distributing it to the wide world. And ours is also a lot cheaper as we use gases to grow it compared to petroleum in the major competition. So our main markets right now are bottles, the medical areas, and food wrappers, and bottles and food wrappers, as we know, are a huge portion of the world's pollution, and is something that we actually solve, because although people will still be using as many bottles and food wrappers as before, but once you throw them out on the ground or out recycle in the garbage, in only 2 weeks, they'll be back into dirt, which will be more homes for plants, more homes for animals and the insects living in them. Also medical. Although stroke looks like a very flexible kind of plastic, it's actually with some proper procedures and strength pushed into it, compressed into it, it can be as strong as aluminum alloy, but only half the weight, and therefore it can also be applied to the medical industry. But another industry that these other companies cannot compete in is the space industry. We hope that FertiPlastic can become a widely used plastic in space compared to the status quo, because in FertiPlastic, in space, you need light, because on spaceships there's a maximum heaviness you can have. It needs to be light, and compared to the competition, once the astronauts get into space, they can actually grow plants with our FertiPlastics, and it'll biodegrade, which means that you don't have to ship the garbage back to Earth, or you don't have to ship the garbage into space, making our space a lot worse. And like I said already, the cost of it will be much lower than paper, much lower than plastic, and as we already know, paper bottles are actually more expensive than plastic bottles, but ours will be cheaper than both of those, as we don't use petroleum or trees to grow our products. Although the buyer value might still be the same, it's just a bottle, it's just a wrapper, it does the same thing, it's a much bigger value to the world's ecosystem and anyone that cares to protect it. And we also have the 4 parts of the blue ocean strategy. So we eliminate pollution and wastelands because if you throw our waste into these wastelands, it just biodegrades in 2 weeks. It becomes pretty much dirt. You can grow things in it. It reduces cost. It reduces danger from microplastics. It reduces danger in the oceans, in space, in the future as we go to space. And it raises a lot more money because a lot of money is right now is spent on collecting this pollution, making pollution easier, but now we can spend it on much better other things, like education or just better things, maybe military if you're into that, which creates, and with more money we create innovation, and we raise innovation like that and create competition, actually, because more innovation creates competition and a sustainable world in the future, but more importantly, a new industry. And that's what I would like to say. And thank you, and please invest in our company for FertiPlastics.